Hi children, in previous video which concept you learned from the chapter 10 SSC real numbers, that is rational numbers and their decimal expansions. Now in this video we will learn one next concepts. Those are theorem 1.3 statement, theorem 1.4 statement and theorem 1.5 statement. What is today's class concept children? Theorem 1.3 statement, theorem 1.4 statement and theorem 1.5 statements. Let us start with theorem 1.3 statements today's class. In theorem 1.3, the statement is given is let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p divided by q, where p, q are co-primes and the prime factorization of q is 2 power n, 5 power m, where n, m are non-negative integers. Understand children? Theorem 1.3 statement in my words. Once again, I repeat the statement of theorem 1.3 is let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p divided by q, where p, q are coprimes and the prime factorization of q is in the form of 2 power n, 5 power m, where n and m are non-negative integers. Non-negative integers means positive integers. In board only I have written the statement of theorem 1.3. Let us see here also with boldly. Let x be a rational number. Let x be a rational number. You take whose decimal expansion, whose means x only, x means rational numbers only, whose decimal expansion is terminates. Terminates already, terminate decimals you learned in previous video one. Let you recall that while see previous video. Then x can be, x means rational number only according to theorem 1.5 statement. Be expressed in the form of p divided by q. In the form of what children? P divided by q. Here p and q are co-primes. P and q are what children? Co-primes. P and q are what children? Co-primes. Co-primes means we learn already in earlier classes. Co-primes means no more common factors other than 1 is known as co-primes. And the prime factorization of q. Here you do p on q, q you do prime factorization. Prime factorization of q is in the form of 2 power n, 5 power n. After doing the prime factorization of q, it is formed 2 power n, 5 power n. Here m, n are non-negative integers. Non-negative integers mean positive integers. Understand children? Let us see with the examples. Here I take rational number, that is x, 16 divided by 125. According to theorem 1.3 statement, what to do children? Q, do prime factorization. Here q is what? 125. I done prime factorization of 125. It will become 5 into 5 into 5. That means exponentially write 5 power m. That is here statement given 5 power m. Here m is non-negative, that means positive only, and it is in the form of 5 power m. So then here 16 by 125 is terminating decimal according to the theorem statement 1.3, theorem 1.3 statement here. Understand children? Here observe, without doing actual division, we find the rational number is terminating decimal. The rational number is terminating decimal. The theorem statement 1.3 that only tell to us. Okay children? Let's see another example. I take here x as 25, 30. 35 divided by 32. That is rational number. Here what you do? You do q. What? Prime factorization. I done here 32 as a prime factorization. It will become 2 into 2 into 2 into 2 into 2. That means I express in the form of exponentially, it will become 2 power 5. Here in statement After doing prime factorization, the formation will become 2 power n and 5 power m. It become 2 power m. The 25 by 32 is what children? Terminating decimal. The rest number is terminating decimal without using actual division. Let us see another example also. Here I take x. X means rational number 35 by 50. Here what you do? Here q is to prime factorization. I done 50 as prime factorization. Here will be 50 will become 2 into 5 into 5. Then I write exponential formula 2 power 1 and 5 power 1. See, after doing prime factorization, the formation will become 2 power n and 5 power n. Then it is the rational number. It is said to be what children? Terminating decimal. Understood children? Theorem 1.3. Okay. See, theorem 1.3 tell us what? Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p by q, where p comma q what? Co-primes. What children? Co-primes. And the prime factorization of you do q, not p, not p. You do prime factorization denominator q. Do the prime fraction of q is when do prime factorization, the formation will become 2 power n, 5 power m, where n comma m are what children? Non-negative integers. That means positive integers. We proved with examples only. The statements written with examples also. Okay children, take rational numbers and without using actual division, we do according to theorem 1.3, change the q prime factorizationly and the formation will become 2 power n, 5 power n. Then it is said to be terminating decimal. The rational number is said to be terminating decimal. Understand children? Next, our next theorem is theorem 1.4. Our next theorem is what children? Theorem 1.4. Let us see. Theorem 1.4 statement is what given. Let x is equal to p by q be a rational number such that the prime factorization of q, here also q you do prime factorization, is in the form of 2 power n, 5 power m, where n, m are non-negative integers. Then the decimal expansion, x that means x here, decimal expansion which terminates. The statement tells us what means. Here the decimal expansion terminate means it is said to be rational number. It is said to be rational number. The statement what tells us means when the decimal expansion terminates, terminate means after decimal point the numbers will stop. The continuous of numbers will stop. That is decimal terminates means it is must not said to be rational number. Here same without using actual division only. Here we done. Okay children, let us see one example. I take x what children? Rational number 7 by 8 is equal to what you do according to theorem? Do prime factorization. What? P or q? Q only. I done prime factorization of 8. It will become 2 into 2 into 2. 2 into 2 into 2. Then I write here 2 power 3. Sir, what do you write here 5 power 3? Why sir? Why you write here 5 power 3? Why? Means the prime factorization of q equivalent to the other rational number a by b. Here b is the power of 10 means you easily find the decimal expansions. Understand children? Why I equivalent here 5 power 3 and 5 power 3? We equivalent the prime factorization of q to another rational number a by b. Here b is will become to 10 powerly, then you easily find decimal expansion. Decimal expansion. That's why I take this example. I done that method. Okay children? Why I take here? I equivalent to prime factorization of q another rational number. See, I taken denominator 5 over 3 and also numerator 5 over 3. I equivalent to the this another rational number a by b. Assume that a by b. Here I b will become 10 power any 10 power n 10 power 3. We find easily decimal expansion. Okay children, what our This 1.3 theorem is tell means let x is equal to p by q be a rational number such that prime factorization of q is in the form of 2 power n only, but the decimal expansion terminates make it is must said to be rational number. Okay children, it is also used without using actual division, easily find it is a rational number. Okay children, next we go for theorem 1.5 statement. Our next theorem what children? 1.5 statement. Let us see 1.5 statement what tell us to. Let x is equal to p by q. Here also you take x is equal to p by q. Here p by q is rational number. Here p by q is rational number. Such that the prime factorization is not in the form of prime factorization is not it is not what? Q. Prime factorization of q is not in the form of 2 power n, 5 power n, 2 power n, 5 power n, where n and m are non-negative. That means positive integers. Then x has the decimal expansion which is non-terminating repeating. That is non-terminating recurring also. Children, we learn already in previous video clearly rational numbers and their decimal expansions. Rational numbers and their decimal expansion. Terminating decimals, non-terminating decimals. And also we discuss types of non-terminating decimals. Non-terminating, repeating decimal, non-terminating, non-repeating decimals. By these theorems, what you tell us means without using actual division, we easily find the rational numbers are terminating decimals or non-terminating decimal. Okay children, what here theorem 1.3 statement tell to you? Let x is equal to p by q is a rational number such that the prime factorization of q, here also q only you take, do prime factorization, but is not in the form of 2 power n, 5 power n, where n comma m are non-negative integers. Then x has decimal expansion non-terminating. Then this theorem tell us what means not in the form of 2 power n, 5 power n, those rational numbers are non-terminating decimals and non-terminating repeating decimals. Okay children, this theorem tells us what? Where not in the form of but prime factorization of q, that means p by q, then q is denominator here, that q is you done prime factorization, but the exponential form is not in the form of 2 power m, 5 power n. It is not a terminating, it is a non-terminating. The decimal exponential will become non-terminating. That theorem 1.5 tells us. See examples also here I given. Here I take x rational number, p is 100 here, q is 81. Which one you do prime factorization? Q only, that means denominator. I done 81 prime factorization, 3 into 3 into 3 into 3. I write exponentially 3 power 4. It is not in the form of according to theorem 1.3. It is not in the form means the rational number is non-terminating repeating decimal. Okay children, see here tell x has, it is not in the form of 2 power and 5 power means x has decimal expansion. What children? Decimal expansion. What here? Terminating, non-terminating repeating. Non-terminating repeating. Understand children? See here also q is not in the form of 2 power n, 5 power n. Let us see another example here. I take a rational number p by q. Here p is 41, q is 75. Which one you do? Prime factorization. Denominator only. A denominator is what? 75. I done 75 prime factorization here. 3, it will become 3 into 5 into 5. The exponential form will become 3 power n into 5 power 2. But the decimal expansion here was not in the form of 2 power n, 5 power m. See here 3 came. The combination only 5 power what means 2, but 3 came. That's why it is also not terminating decimal. Non-terminating decimal. Understand, children? Here 5 came, but here formation what? Not in the form of 2 power and 5 power. So here 5 came, 2 not here. That's why it is a non-terminating decimal. Next we see another example. 129 by I already done directly exponential forms. 2 power 2, 5 power 7. Sir, here 2 power. So it is not in the form. 7 power 5 also came here. Here 2 power 2 came, 5 power 7 came, and 7 power 5 came. So not in the form of 2 power m and 5 power m. It is in the form of, it is called as non-terminating decimal. The question number is called as non-terminating decimal. Understand, children? Today's concept. What today concepts you learn? Statements of theorem 1.3, 1.4, 1.5. Let us recall once again the statements. Theorem 1.3 statement. What tell to use, children? Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p divided by q, where p, q are coprimes, and the prime factorization is in the form of 2 power n, 5 power m, where n, m are non-negative integers. Next, what tell theorem 1.3, 1.4 statement, children? Let x is equal to p by q be a rational number such that the prime factorization of q is in the form of 2 power n, 5 power m, where x has n are non-negative integers, x has decimal expansion terminates. X has decimal. What theorem 1.5 tells us? Statement. Let x is equal to p by q be a rational number such that the prime factorization of q is not in the form of 2 power n, 5 power m, where n, m are non-negative integers. Where then which decimal x has decimal expansion non-terminating decimal. That is the statement tell theorem 1.5. Okay, children, we learn carefully, learn by heart the statements, learn each word what is given, and learn carefully what is given in statement. These three statements use is without using actual division. We find easily the rational numbers are terminating decimals and non-terminating